I'd like to start this video by giving you a few hints or tips on using Model Builder and the debugging of models. If you get a complex model like this one here, this calculates the surface absorption, the maximum surface absorption in our problem. You can have quite a few steps, and often it won't run right the first time, or even after multiple times. You have to try and figure out where your error is. And that's often difficult because you get very cryptic error messages from the Model Builder validate run steps. So one of the things that I do to help is, first I set up an environment where I have a scratch and a current workspace that are different. So the current workspaces are typically where I have my base data, and then I create another directory, and I typically name it Scratch or Scratch New or something, and I call it the Scratch workspace. That means that all of my intermediate data can be copied there or shunted there during my processing, and that way I can look at the results there instead of having them proliferate inside my regular geodatabase. And so what I'll do first is create that Scratch geodatabase and go into this environments variable in the Model Builder, environments tool in the Model Builder set of tab tools, and I'll set that Scratch workspace as the target of my output. And then I'll copy my original data from wherever I have it. In this case, it can be in the whole project data, or if I'm working along, I've done work before, it might be in my ongoing geodatabase. And I copy it into then this Scratch, and I'll pull from here and set the input data from the Scratch database. So for this model, I'm working here with its own set. Now in a different model, I might set up another different Scratch geodatabase if I have it within the same project. So I can see where the output's coming from. And then in addition, if it makes any modifications to the data or crashes or does anything, it's not going to ruin my base data. So this way I kind of wall off where my work goes. So here I want to show how I set up the workflow that calculates the maximum surface absorption. And it more or less follows the flowchart that I handed out in class. So I start out with this surface permeability variable, and it has various surface types in it, pervious and impervious, and I calculate a field based on that. So if I open this and take a look at it, it shows that it basically calculates the pervious code, right, which is a variable that I've added. It has that 1 or 0, and if the infill type is pervious, it basically gives the pervious code that value. So I add a pervious code before I come in to this analysis. If I don't have that already existing in my data set, I could go ahead and add the pervious code before I start, but in this case, I assume it already exists there in my model. And I use this if statement. So I have this code block that I use, and this just allows me to not have to do a selection and assign and another selection and assign. So I save some few steps. I could do, as I've shown you earlier, where I'll select the set where the infill type equals a pervious, then I could do a calculate field to calculate a value of 1 into the perv code, and then I could select a different set, that is the set where it's impervious, and give it a value of 0. So I could do that with 4 or 5 operations, but here I'm doing it with 1 in this code block. And basically, to use a code block, you have to say the type. This is a Python code block. There are a couple other kinds that are there. And then you pick the variable you want it to land into, the field name, in this case perv code. And then you do this asp code by surf type. And basically what you're doing is you're generating the name. I just typed this in, decided that's what I wanted to name it. And the surface type is the main variable it's going to pass. And so it'll go to each record and look at the surface type. And here it's called infill type, just so I don't get confused. So it's infill type. If the infiltration type is equal to pervious, so the value that I've passed through, for the record, the surface type is pervious, it's going to return a value of 1 and then assign that to pervious code. If it's not pervious, so that's what this elif does, else if it's impervious, it's going to return a 0. And if it's neither of those, it's going to return a -9999. That means a flag where somehow I messed up or didn't add for this infiltration type for the ground surface, either pervious or impervious. Now remember, this comes from our surface permeability layer. And so if it's set up wrong, I have no chance of getting the right answer. So that's pretty straightforward, and I get a new surface out of that. And the buildings, then I'll calculate the field in the building. It's kind of the same idea. If I open the buildings here, I'm basically calculating the field for the roof, and it's the same thing. I have a building absorption layer, and I'm going to pass the roof variable through. Remember, the roof has flat or pitched or green in it. And I have this assign roof function, which I'm defining down below, and it operates on the roof. And it says if the roof type is flat, return 0. That's the absorption of a flat roof. If it's pitched, return 0. That's the absorption of a pitched roof. If it's green, it's 0.05 meters. That's the absorption of a green roof. Else it returns a -1. Again, a code. And so that's an error code, lets me know something's messed up. So what I will do is basically change any building that I'm going to make a green roof. First look and see how it's a flat roof building. I could take that flat roof building and change the value for that building in that row for the roof type to green, right? I got to type it in right, capital GREEN. If I don't, then I'll get that -1 error flag. So I'll calculate that field and get a new buildings layer and see it's going into that scratch geodatabase, and I'll union those. And then, as the union typically goes, I have to multi-part to single part, and I get this new layer, build permanent single part. I'll add a field for surface absorption, and so here I'm basically putting in a new field type, which is float, right? It has to be a real number, single precision. It has 8 spaces, 3 to the right of the decimal place, and it's nullable. So I create that field. Then I'll select those records that have a pervious code of 0, and that's basically all those flat areas that aren't buildings that might have a pervious code that's concrete, associated with concrete. I'll set the surface absorption to 0. Those can't absorb anything, and so the surface absorption, the maximum, is 0. I'll clear that selection because I'm going to be basically unioning this, and I don't want the union to only work on selected features, so I have to clear them. Otherwise, the union would only grab those features that are impervious that I had already previously selected and union those with the soils. So I'll soil that. Union out with the soil, then the multi-part to single part again. I get this new layer, and then I'll select those with a pervious code equal to 1. So those are the values for the areas that are pervious in the land cover layer, because those will be the ones, and there may be some additional ones, but we'll clean those up later. So again, I'll union those, and then I'll set the surface absorption for those in this calculation to the value that's found in the soils layer. The soils, remember, brought along a maximum absorption associated with the soil, right? This max infiltration. But that's in centimeters, so I divide it by 100. So I'm taking all the surface absorption values, but these are the selected ones, remember, and I'm assigning them a value of the maximum soil infiltration. So the selected ones are the pervious ones. Now when I did this, as I described earlier in a previous video, all the buildings also have a surface absorption parameter, and it's 0. It basically, in that pervious code, or when it comes through, they get assigned a value of 0 also for that per code and for. So what I want to do is basically now assign the buildings correctly into the surface absorption section. So I assign the surface absorption based on the building absorption variable. So what I'll do here is select the buildings, right? So I'm going to basically find all those rows where the roof is equal to flat or pitched or green, because the roof only comes from the building layer, and the building layer doesn't overlap with any of the other layers. Remember, the buildings were punched out. So there's no pervious or impervious. I'm picking those polygons that got unioned together, and the roof is only defined for those polygons where they're building. It's null or 0 or 1 or some other number in every other part of my database. So if I select any of these areas, those are guaranteed to be in a building. And then I can assign the surface absorption based on the building absorption variable. So I have that building absorption variable, which was set to, as I showed it earlier, what the green or flat or pitched value was. And so it's going to be 0 where it's flat or pitched, and at 0.05 where it's green. And so I then clear the selection, and I could, if I'm doing just a vector analysis, then overlay this soil built SP with my other layers and continue my analysis. But if I'm going a raster option, I'll polygon to raster and I'll get my output. So this is the way we walk through. The only thing a couple things that are a little bit different are those assignments at the start where I use that if-else statement. Again, you don't have to do those. You can do the easier select, assign, select another set assign, select another set assign to get the various combinations that you need. This just saves a few steps so that this workflow doesn't get even bigger. When I run through that analysis, I end up getting basically an output that shows up here. And I've done that before. I get the surface absorption layer. And that surface absorption layer I then will load onto my map, right? And I'll verify that it gives me the right value. Now, a couple of things. When you go through and run your model, if it hangs up and you can figure out the error and then continue to keep it to run, it should be fine. If you run and the model completes, but you find something wrong and then you go back and change some of your steps, like maybe my assignment was wrong, I was selecting the wrong thing, it's better to go into the scratch and delete all the new intermediate variables, layers that it created. So when I run this model, I'll get a bunch of intermediate ones that show up here. These single part to multi-part or other things will show up. The union ones will show up. You generally want to remove those because sometimes you generate a change and it skips over something or it doesn't write something, and you're looking at an old version output. So you might be looking at a intermediate variable or intermediate layer that came from 3 runs ago. It doesn't get output, you're not really sure where it is. So it's best to get a clean slate and to see when it hangs up what the values are here in your Scratch2 database. I'll go ahead and run this and I'll show you a picture at the end after I validate it, what things look like. Okay, and so when it runs at the end, nothing seems to have changed my Scratch2 database, but I'll right-click and refresh it down here off the bottom. And you'll see there's all these new data layers in here, including my final data layer. So these are all intermediate data layers. The soil building SP, the soil built U, the build perm SP, those are all new things it's created. And if in the debugging you run into some issue, it's best to delete all these and then rerun it and have them create them anew if you're using them to try and determine where your error is. So that's it.